Good morning.
Good morning. Can I ask something? When I tried join to your lesson, I mean Zoom link with my laptop, it's crashing. I don't know why.
Sorry, what?
It is crashing.
What is crashing?
Zoom is crashing.
Let me put on. No, you can.
Like just kicking me out of Zoom and just not opening the lesson. Only with laptop. I don't know. And only this lesson. The others works well.
Again, when you join this lesson, you're crashing, but on Zoom.
Yes, but other lessons and even when I create meeting, it works well. So I have no idea why would it. But
Okay.
I still can join with my phone, so that's okay for me.
Okay. So you're joining by phone only.
Yeah, only phone. I can.
But this is. But can you see the videos afterwards?
You mean the recording?
The recordings, yes.
I haven't tried. I will try.
Okay. So you don't miss it.
Okay. I actually joined never lesson, so I haven't used it to view the recording. I will try.
Okay. So we will wait 2 more minutes and we will start today's lecture. How many of you have tried to deal with the exercises? I know it was ungraded, but I only saw one person, one student who actually tried to or submitted. Did any of you who didn't submit try to deal with that, try to solve that?
We have viewed with like 4 or 5 students together.
Okay.
Yeah, actually, I also did submit.
Okay, good. By the way, so you went online and you were able to connect to the Moodle and you were able to see the exercise and submit and everything was okay?
Yep, no problems.
Good, good. I'm happy to hear. Okay, so let's, how many people do I have? Right, 6 people. That's, I would like to see more people and I would like everybody to open their cameras, please. You can mute, but please open your camera. Okay, So I see that there are already some people. Mikhail, hello, good morning. Azizbek, good morning. Amanova, Nilofar, good morning. Iroda, good morning. Endrechim, good morning.
Good morning, teacher. Good
How
morning.
are you?
How are you?
I'm fine, and you? Everything okay?
Thank you.
Good, good. Oh, I'm happy that at least one person opened their cameras. Please, everybody open their cameras. I'd like to see your faces, your eyes. I want to see that you're I see in the eyes if you're understanding things, or if your eyes are glazed, I know that I'm not with you, or you're not with me. So it's very important for me to see your faces. Good. So good. Nice to see you people on camera. This is
Thank
very
you. Thank you very much.
You're welcome. So let us start. Last lecture we talked about the stages of data science, and we started talking about the tools of the trade. And I understood that around half of you are beginners at Python, and around half are intermediate. So today what I want to do is a brief introduction on Python. I will do it rather quickly in the first hour. In the second hour, we will talk about pandas. Pandas is the library that deals with data analysis in Python. Okay, so this is what we're going to do today. We are not everybody here, but I'm usually not waiting, so everybody know that I'm starting in time, and please, everybody needs to know that they need to be on time. Okay, so if you're not coming in time, you will miss part of the lecture, part of the material. So without further ado, I will share my screen. Okay, so again, today's lecture will be about a short review of Python, and we will go into pandas. So as I said last week, the tools of the data scientist are, of course, spreadsheets, but this is very rudimentary and I would say a primitive tool for very small data sets. If we want to go automatic, if we want to go dive into deeper into the analysis, we will use Python, and the main tools that we will use in this course are Jupyter. It's basically a notebook. It allows you to open a notebook, not just code, but also write your analysis, and since this is designed specifically for data analysis or data scientists, this allows you to write your analysis on the data as well as code. Okay, so this is a scripting notebook, and Pandas, which is the data analysis library of Python. There are more tools that we will go only briefly in this course. NumPy, SciPy, pandas that I already mentioned, and scikit-learn. And there are also two visualizations libraries that we will not dive deep into. We will just mention and use them, which are Matplotlib and Seaborn, which allow you to do a visualization of your data. Now, a bit about Python. So Python is a general purpose interpreted, interactive, object-oriented, and high-level programming language. Okay, general purpose, it means that it's not it may be used for different purposes, such as for web applications, for Internet of Things, for data science, which is what we do, and so on and so forth. It's not purposely built for only one objective. It is interpreted, meaning that it is not compiled. So we do not compile it into a machine language and save that file as an assembly file and then run it. No, we save our file as a Python file, and it is interpreted during running. Okay, it is object-oriented. Okay, I'm sure everybody here knows what object-oriented means, but in general terms, it is, even though you don't have to write it in an object-oriented way or methodically as an object-oriented language, and we will not write it as an object-oriented language. It is still object-oriented behind the scenes. Okay, the language itself is object-oriented, and everything in this language is an object. I will not delve deep into that because that is not the main focus of our course. But know this, that Python, even if you do not write it as an object-oriented language, it is still an object-oriented language. And of course, it is high level. It's very easy to learn it. It's a language that has a syntax very close to the English language. In terms of history, it was created by Guido van Rossum during the late 80s of the last millennium, and it was and still is public property language. It's not a private property. It's not a proprietary language like let's say C#. Okay, so it's a general public license language, and the code is available under GNU. So as I said, Python is interpreted. Okay, it is processed at runtime by the interpreter. It's not compiled prior to execution and saved as an executable assembly. It is interactive. Okay, we can in some IDEs we have Python prompt that we can actually interact with, and the interpreter directly interprets our commands. And as I said, it is object-oriented. Okay, so the features of Python are as follows. One, it is simple. Two, it is easy to learn. It is free and open source. As I said, it's a high-level language. It's portable. It doesn't matter which. It can run on any machine, whether it's on a Linux machine or a Windows machine or an OS machine. Doesn't matter. As I said, it's interpreted, object-oriented. It is extensible. Okay, you can import libraries, and it is embeddable. Okay, you can use libraries that you wrote in Python, and of course it has an extensive set of libraries. The syntax of Python, I will go through it very fast because we had my assistant taught you that last lecture. I will only go through some rules. Okay, so the hash mark indicates a comment. A new line or an enter when you press on the keyboard is the standard line separator. The backslash continues a line if you don't want a new line. A semicolon joins two statements on a line, and again, this is not something we would normally do. I would strongly recommend against it. A colon separates a header line from its suit. So, for instance, an if condition or a for loop from the suit that follows it. The statements, the blocks, are grouped as suits. Again, after an let's say an if statement or an if conditional or a for loop or a while loop, and the suits delimited not with brackets, but with indentation. Okay, and the Python files are organized as modules that you can import and run and whatnot. So again, Python works with an indentation. You do not use curly brackets, okay, to indicate that you're in a block of code. Okay, for either class or function definitions or flow control. Okay, you do not use curly brackets, but you indent them. Okay, you denote the blocks of code by line indentation, and this is rigidly enforced. And again, For instance, we saw it last lecture. If some condition is true, if true, and then you put two dots, print true. Else, and again, print two dots, print false. And you see that the print true and print false are indented. Okay, because they, and if I wanted to add more lines of code, they would have the same indentation, and this is strictly enforced. If you have a bad indentation, you will get an error message. Okay, so this is not just stylish like in other languages, like in C or C++ or C#, but this is strictly enforced. This is part of the syntax. Quotation. We can use either a single, a double, or a triple quotes to denote string, but they have to, you have to use the same quotes, the same type of quotes, either single, double, or triple, at the start and the end of the string. The types that Python supports are numbers, okay, and these divide into 4 separate subtypes. Let's say integers or regular or plain integers, long integers, float, and complex numbers. Okay. I don't think we will use complex numbers in this class, but we will use all the other subtypes. Strings, of course, a list, a tuple, and a dictionary. Okay, and we went through. I think we went through we went through, I think, all of the standard data types. There are, of course, many other data types that you can import the library. For instance, there is a library called the containers that you can add, and it will have other data types as well. Assignment of data is done with the equal sign. Okay, so on the left of the equal sign, you have the name of the variable to be assigned to, and on the right you have the value that's stored in that variable. Okay, and if you put an integer, you will get an integer. If you put a real number or a floating point number, you will get a floating point number. And if you put a string in there, you will get a string. Okay, it's very straightforward. You don't have to announce your variables before assigning a value into them. Now, let me talk about lists. Lists are the most versatile of Python's compound data types. Okay, they are a container that contains many values, and they contain many items, and these items are separated by commas, and they are enclosed in square brackets. Okay, square brackets like this. If you're familiar with C, then lists are similar to arrays in C or in other languages. However, one difference is that, as I'm sure you all know, that in C or in C#, if you have an array, you have to declare it first, and you have to declare its size, and all the items in that array have to be of the similar data type. For instance, an array of integers, or an array of floating points, or an array of chars, of characters. Okay, in Python, all the items in the list can be of different data types. Now, if you want to access one item in the list or several items in the list, you use the slice operator, which again is square brackets. And these square brackets can either be a single item, and then this would be just one item. And if you add a column, then you can access several values. For instance, if I want to take just several items in the list, I would write list and then square brackets, and between them, let's say I want the items between the 3rd and the 5th item. So I will use 2 and 5. Okay, I will add 2 colon 5. So just to remind you that Python in Python, the first item is numbered 0, not 1. And the last item, by the way, is labeled. If you want to access the last item, regardless of the size of the list, you will use -1, and then the one before it is -2, and so on and so forth. Okay. Now, you can add 2 lists together with a plus sign, and also you can repeat a list with the asterisk sign. For instance, let's say I have a list. By the way, this is a bit old, so all the print statements here have no parentheses. That is Python 2. Right now, we're in Python 3. You need parentheses when you use the print command. So just be aware of that. If you try to print something without parentheses, then you will get an error message. Okay, so this is a bit old. So if I have, if I assign 2 lists, one is called the list and one is called the tiny list, and you can see that both of them have, for instance, the first list has both string, integer, and float values, and tiny list has an integer value and a string value. I can print the entire list. I can print just one element in that list, which would be A, B, C, D. I can print the second until the third elements in the list, or I can print the third element and all the way to the last element, that is 2 colon, or I can print all elements until a certain element, okay, that is colon 3. And I can also print the list twice. So if I print tiny list times 2, I will get 1, 2, 3 John, 1, 2, 3 John. Okay, twice that list. And of course, I can add both lists to get a longer list. Okay, so another data type that we know of is a tuple. Basically, a tuple, we denote a tuple with, instead of brackets or square brackets, with parentheses, round parentheses. The main difference, I will not go deeply into tuple. The main difference is that a tuple is immutable. Immutable means that it is constant. Once we assign the value, we cannot change them. The benefit of a tuple is that it's more compact in terms of memory use. Okay. Sometimes we will use tuples, for instance, to define the size of images and so on and so forth. This is not something that we normally use a lot. The third container that I want to discuss is a dictionary. Again, if all of you understand, have experience in coding, so a dictionary is like a hash table in other languages. We have an associative array of key and value pairs. Okay, so you have a key and you have a value for each pair, and the keys can be any type. They don't have to be a number. They can be a string, or they can be any object that you want. But normally they would be a number or a string, and values. Sorry, what? I will give a time for questions in a few minutes. And the values can be any arbitrary object. Okay, and dictionaries are enclosed by curly brackets. Okay, so this is not the main reason, but in other languages, curly brackets denote the code blocks. Here, curly brackets denote dictionaries. Okay, so we thought that we will not see the curly brackets, but we see them in a different way. So again, if I want to, I can declare an empty dictionary. Okay. all I have to do is just write curly brackets, and this is a dictionary. I can, and then I can add to that dictionary other pairs of keys and values just by placing, again, using the square brackets to denote slicing. Okay, so I want to add a key and a value to the dictionary, with the key being one as a string, and the value being another string saying this is one. Okay, and then I denote, then I add one more item to that dictionary, and this item has a key of 2 to the number, the integer number 2, not the string 2, and the string will be this is 2. Okay, and the same in the same way I can also define another dictionary, let's say tinydict, with pairs of keys and values. Okay, with colons between them. So I have a pair called name and the value John, a key called code and the value 6734, and see that that value is an integer, and the key called department or depth, and the value for this key will be sales. Okay, so if I print this, I can print the dictionary. I can print only a slice of the dictionary. Okay, I can print the entire dictionary, or I can print only the keys or only the values. Okay, so this is, I'm sure all of you have experience with hash tables. So a dictionary is very much like a hash table in other languages, as you can see. Now, the operators that we have in Python are arithmetic operators, plus, minus, times and division, multiplication and division, and of course power, and all sorts of arithmetic operations. Comparison operators, okay, equals to, larger than, smaller than, larger or equal to, not equal to, and so on and so forth. Assignment operators, we've seen that before. It's the equal sign. Logical operators, logical and, logical or. Bitwise operators, again, bitwise and, bitwise or, bitwise XOR, etc., bitwise not. Membership operators, I will not go through that very deeply, but you can see if a certain item is a member of a list, okay, in a list or not in a list. And identity operators are if you have two names of the same variable and both of them point to the same place in memory, then you will not use an equal a comparison operator. You will use an identity operator called is. Okay, if A is B, means that not only that their value is equal, but they point to the same place in memory. Okay, conditionals. So we have an if statement. Okay, if a certain expression, then colon, then we indent and put our statements. An if else statement. Again, if some expression is true, do some statements, and again, this is a code block, so we indent that. We return the indentation, write else, colon, and again a block of statements. So if we have nested if statements, we will have an if, elif, else, if, elif, else construct. Okay, and these will be nested. This is very similar to other languages. A while loop. A while loop allows us to execute a statement or a group of statements multiple times until a certain condition is met. Okay, so for instance, we initialize count to 0, then we write while count is smaller than 9. We print the count, and then we add 1 to the count, and of course. Python also, this could be written as count is increased by 1. Okay, there is no, in Python we do not have, if you're coming from C, we cannot use the increase 1 operator like this. Okay, this will not work. Okay. We don't have that in Python. If you're used to using that in other languages, you will not see that in Python. Any questions so far? Okay, so I will let us go. If are you sure there are no questions whatsoever? No questions. Okay.
I'm sorry, I have a question.
Yes, please. Okay.
It's about the lists. Can we like go to the lists presentation?
Yes.
Yes, here. It no like one. Yeah. It says here like you see print list 1 to 3. It says prints elements starting from second till third.
Yes. Why is that? Can you? I'll let you answer your own question. You remember what is? Look at one line before that. What is the first element numbered?
On the list,
Yes.
it's 786.
No. See one line before. If I want to print the first element of the list.
Yeah, we write 0. I know that.
Exactly. So
But
the first element will be 0 and the second element will be 1. Okay.
oh,
Okay.
okay. Yeah, I understood.
Okay. Good. And the third element, this is when we write one number colon the second number, this will not go into the slice. This is the one that this is we will count until 1 before that. So it will be between the second and third, not the fourth, even though this is 3. Okay.
Yeah, I
So
understand.
this would be 0. This would be 1. This would be 2, and so on and so forth. Any other questions? Okay. Okay. By the way, it's not mentioned here, but if I want, I can use 2 columns. For instance, if I see a list two columns and then let's say 2, this will be the step size. So I will get the first item, the third item, and the fifth item. Okay. And if I do a list with a negative step number, what will I get? Can anyone tell me? Anyone has an idea? Okay, so what I will get the same list, but in reverse order. So I will get 70.2, John, 2.23, and so on and so forth. Okay? So for instance, since a string is basically a list of characters, what happens? How can I how would I see if a certain string is a you know what a palindrome is? You know what a palindrome is? It's a sentence that, or it's a string that you can read from the start to the end and from the end to the start the same way. So if I want to test if a certain string, let's say an A, okay, is a palindrome or not, all I have to do is see this. Does A equal A, 2 dots, or colon, -1. Okay, this will check if this particular string, if A is a string, is a palindrome or not. Okay, so as you can see, this is very high level. Okay, any other questions? Good. So I didn't mention it, but we also have sets. Sets are like lists, but two differences. One is that sets cannot hold more than one instance of the same item. So if a certain set has, let's say here, if this was a set, a list can have another one more item called ABCD. Okay. But a set will erase that. Okay. If I tried it with the set, it will erase that. And also a set is not ordered. So if I try to take a slice from a set, I don't know which item I will get. I can get any item, doesn't matter. Okay, it is unordered. Again, we will not use a lot of sets in this course, so I'm not going a lot through this. Now, as I said, Python has. We talked about while loop. Let's go over for loops. A for loop is different from other languages. A for loop, we iterate through a sequence. Okay, so for instance, if we have a list that contains 3 items: apple, banana, and carrot, and then so this is my list, and now I write a sentence for fruits, for fruit in fruits. This will go through this list, so it will print apple, then banana, then carrot. Okay, if I want to loop over a certain number of iterations, so the for loop in Python is like the for each loop in other languages. Okay, and if I do want to use the for loop as an iterator over a certain number of iterations, then I use a range. Okay, so I would use for num in range.
Can I ask a question?
In a second. Okay, in a second I will give time to ask the questions.
Okay, thank you.
So I will use, for instance, if I want to iterate over, let's say 10 times, regardless of a list, I will use the keyword range. So this has 2, but doesn't matter. If this will iterate in a range between 10 and 20. Okay, so 10 times. Okay. Yes. So now, what was the question, please?
Yeah, I want to clarify for myself. In other languages like C++, our for loops starting search from 0 point.
Yes.
Is in Python it's like this, or it's starting from 1?
It's starting from 1. And usually, what you would want to do, for instance, in Python, the syntax will be like this: for I in. I'm sorry about my. It's difficult to do it with the mouse. In range. Let's say I want to run 10 times. I will write just 10. Okay.
Okay,
And,
I understood it. Thank you for your answer.
You're welcome. Now, one more thing. Let's say I have a list, and let's say I have a list. I want to write the let's erase it. So let's say now I have the list, and I want to print not just the fruit, the name of the fruit. I want to print the name of the fruit and the place. So what I will do, I will use the keyword enumerate. So I will use for fruit instead of this. I will use for. I will also write this for I and fruit in enumerate. Okay, the keyword enumerate fruits print I and fruit. Okay. So what I will get is of course 1 apple, 2 banana, and so on and so forth. 3 caret and so on. Okay, so this is if I want to go through a list or through any container and iterate also a number, what I will use is the enumerate. Okay. One more thing, importing libraries. So we have 3 ways. We have more, but I will mention 3 ways to import libraries that we want to use. For instance, the first one and the most simple one, import pandas if I want to import a certain library. If I want to import the library and give it a name so it will be easier for me to use, I will write import the name of the library and then a shorthand. For instance, I want to import a library called NumPy as NP, and then every time I want to use that, I will just need to use NP, for instance, .ndarray, for instance. We will go through NP in a minute. Okay, so this helps me to shorten this to a shorthand. And also I can import just a certain part or a certain object from a library. For instance, this library is very large. I don't need all of it. I just need the pyplot part. So from the library matplotlib, I will just import a certain part, a certain sub-library. And also, of course, I can also write as, which is very common, as PLT, for instance, because this is used for plotting. Okay. And these are standard libraries that are already installed. When you install Python, you will also already have them installed. But if you want to install a new library that you do not have, then you use pip install and then the name of the library, and you have to do it only once. Once you import it or once you install it, you can use import to import it to any Python script that you want. So, have all of you installed Anaconda with after the class with Elisheva? If you have not, then I'm putting this again. You can just install Anaconda. You will need to install Anaconda. Okay, this is the link to install it. And once you install it, you will have all of these tools at your disposal. We will mostly you will use Jupyter Notebook in this lecture, which is just a web-based notebook environment. And sometimes you will want to use Spider, so you can. Spider runs locally on your computer. So sometimes you will want to use Spider for, and again you may use any tool that you want. Doesn't matter whichever type of ID you want. You can use VS Code if this is comfortable for you. I don't care, but the homeworks, the exercises will be in the Jupyter Notebook. Okay. So, but once you install Anaconda, you will have all of these tools at your disposal. Yes. Any questions?
It's important to install.
What? So everything is important. What was the question?
My question, I just installed Jupyter separately from Anaconda, so also I have my own ID on my computer. So you can
use your own ID. It doesn't matter. You can use your own ID and then copy and paste your code into the Jupyter Notebook, into the exercise Jupyter Notebook. In order to get an assessment, in order to get a grade, you will need to use the Jupyter Notebook that I've seen that some of you have already submitted. So obviously this is working well and you're able to submit. You are getting Vocarium. I already published one exercise that you will need to finish by, I think, I don't remember which date, but you already have to work on that and submit that to get a grade on that. Okay, so this is published once a week, and you can work on these Vocarium notebooks, and and submit and get an automatic grading. Okay, and this is of course, and again, 66% or 2/3 of your grade are based on your exercises, and 33% or a third of your grade, 34%, are based on the project that you will do. By the way, I didn't mention, if we're talking about this, I didn't mention it. I'm allowing people to work in pairs on the project, okay? But just that you know that you will have to defend that project in front of me, and I may ask both people at a certain time to ask one of the people involved, now you answer this question, now you answer that question, so I can make sure that both of you worked on that project. Okay, so I know that in advance. I understand that in Baku we have 5 people, right? So I will allow one group to be composed of three students instead of 2. But this is the single case that I'm allowing. Okay.
Okay.
Any questions so far? About Anaconda, about Jupyter, about how to install it? Anything at all? Nothing. Okay. So I will go over. I have. Okay, we will go and we will continue this lecture until 10 o'clock, and then we'll have a break. Okay. So that we can finish a bit earlier. So the other libraries that we're going to use other than Panda, we will focus on Panda. Most of the course will be focused on the Panda library, but there are other libraries for data science. The first one is NumPy. As I've mentioned, we have lists which are one-dimensional, basically a one-dimensional array. NumPy or numerical Python introduces objects for multi-dimensional arrays. Okay, so matrices and tensors, and also the functions that allow us to easily perform advanced mathematical and statistical operations on these objects. Okay, we will go a bit through NumPy, not very deeply. This is we go more through NumPy when in the next course in advanced data science. Basically, what NumPy provides is vectorization of the mathematical operations so that you don't have to loop through them. Okay, and a lot of other libraries, Python libraries, are built on NumPy. I want to emphasize that NumPy itself is written in Fortran. Okay, so this is a much faster. It's not an interpreted language, but a compiled language, which means that if you make your calculations in NumPy, they will be much faster to execute than if you, let's say, loop through use Python loops to loop through your arrays. Okay, so this is one of the main reasons why we want to use NumPy, because it's much faster, several orders of magnitude faster than just looping through Python loops. The next library I want to mention is SciPy, Scientific Python. And basically, it's a collection of algorithms for linear algebra, differential equations, numerical integration, optimization, statistics, and more done on arrays. So this is built on NumPy, the library that I mentioned earlier. And it gives us further functionality over NumPy. Another library that I want to mention, and we'll go through that library very thoroughly through this course, is Pandas. Pandas is an acronym, but it's a slightly modified acronym. It's Python data analysis. They changed the order of the letters. So instead of Pandas, it's Pandas, because it's a nicer word. It's a very cute animal. And this adds data structures and tools designed to work with table-like data. If NumPy deals with arrays, Pandas deals with table data. Table data means that or let's say in NumPy, all the numbers in the array have the same meaning. Okay, so for instance, if we look at an image is just a three-dimensional array. Why? Because we have 2 dimensions are the width and the height of the picture, and then we have 3 channels, right? Red, green, and blue. So we have 3 dimensions: H, which is the height, W, which is the width, and C, which is the channel. So let's say that it can be 1024 pixels over 768 pixels over 3 colors. Okay, so this is a 3-dimensional array. So NumPy is very efficient in working with arrays in any dimension. Doesn't matter any dimension that you want. And Pandas is very efficient when we work with table data. Table data means that every column in the table has a different meaning. Okay, it's not pixels that all the pixels have the same meaning, but it can have a different meaning. For instance, if we have a table of people, so the first column could be the name of the person, which is a string, and then the second column can be the height, which is a number, which is let's say a height in meters, so it's a floating number. Okay, 1.8, for instance, and the third column can be an integer number, for instance, let's say the zip code that this person lives in. Okay, so this would be an integer number. And what Panda does is that provides us tools for that data manipulation over tables. For instance, reshaping the table, merging tables, sorting tables, slicing, aggregation, etc. We will go much deeper into Pandas in the next hour. And also it allows us to handle missing data. But by the way, I didn't mention it, but there is a vast documentation for all of these libraries, and I give you the link for that. You have a link for the documentation of NumPy. You have a link for the documentation of SciPy, and of course, you have a link for the documentation of Pandas. I will also include a cheat sheet, meaning a very concise documentation of at least Pandas in the Moodle, in the course webpage, so that it can help you during your tasks and during your project. Okay, so this is Pandas. If you remember, I mentioned visualizing. So let's say the main library that we will be using for visualizing is Matplotlib. This allows 2D plotting. It's mainly concerned with 2D plotting. You can also use it for 3D, but it's usually we will not use it for 3D. We'll use other libraries for 3D plotting. This produces publication quality figures or graphs. Okay, in a variety of formats that you can then use in your reports and so on. It's called Matplotlib because it's based on MATLAB. The functionalities are very similar to those of MATLAB. It allows you to do many types of graphs, line plots, scatter plots, bar charts, histograms, pie charts, etc. And it's relatively low level. You need some effort to make it work, and you need more effort to create, let's say, advanced visualization and custom-made visualization. This is why we also have another library called Seaborn, which is based on Matplotlib, but it's more high level. So it allows you to make very attractive statistical graphics in a simpler way. It's very similar to ggplot2 in R. If some of you came from R, doesn't matter. But it allows, let's say, more elegant and more statistically pleasing plots than Matplotlib. Another library that we will go through in this course is scikit-learn. Not today, but further down the line. Scikit-learn is scientific-kit machine learning library. It provides machine learning algorithms, so you don't have to write them yourself. Again, in this course, we will not write the algorithms ourselves. We will use an existing library. In the advanced course, we will write those algorithms ourselves. Okay, so these algorithms allow us to do several things such as classification, regression, clustering, model validation, etc. And this again is built on and uses the libraries of NumPy, SciPy, and Matplotlib. And again, it has its own documentation. Okay, which I gave the link here. We talked about all of them. Now, any questions so far about the libraries that I talked about? No one has any questions? Okay, so the first thing I want to do, or the first thing that we want to do is to import those, if we want to use those libraries, we will need to import them. So the names that usually are associated, the shorthand names that are usually associated with these libraries, and I urge you to use these shorthands and nothing else, is we import NumPy as NP. This is the shorthand for NumPy. This is the accepted shorthand for NumPy. SciPy as SP. Pandas as PD. Matplotlib as MPL, and sometimes, or a lot of times, we would not use all of the entire Matplotlib library. So we will use from Matplotlib sorry. Matplotlib import just the pyplot, and then we will call it PLT as PLT. Okay, again, this is the accepted shorthand for Matplotlib pyplot. And of course, Seaborn, the accepted shorthand for Seaborn is SNS. Okay? Any questions so far? I see that someone asking a question, but he is muted or she is muted. None. No questions. None from Baku, none from Tashkent. Okay. So what I ask you to do now is, how many of you have, and please do it by raising your hand or by writing in the chat. How many of you have already import or installed Anaconda and started working on the first exercise?
What do you mean by first exercise?
I put a first exercise, non-graded exercise on Moodle.
Oh yeah, I did it.
Okay. So 3 out of, let's stop sharing just so I can see all of you. 4 participants raised their hands out of 19. Okay, so not many. So I want you to, I will give you 5 more minutes, so 20 minutes instead of 15. And I want you to please use this time to install Anaconda. I will again put this, I will silence myself and put the camera off. I will go back to the slide that shows you how to install Anaconda, and please use this time to install Anaconda. Everybody who did not install Anaconda yet, and everybody who has installed Anaconda, you are free to go and drink coffee or tea or eat something and so on and so forth. Okay, so I will meet you back at 10:15. Any additional questions before I turn off my camera?
I don't have any questions.
Good, good. Okay, so have a nice break and please install Anaconda, and talk to you back at 10:15.
zakaz barato, to nie?
Okay. Can you hear me, everybody? Can you hear me? So,
Yes,
good. So we'll continue. So I hope everybody has was able to install Anaconda. Hopefully. If anybody had any problems, you feel free to contact Elisheva. She will help you with that. Okay. If there is still any problems, then on Thursday she will do a session to make sure that everybody has it installed and that you can work on your assignments. Now, again, your assignments are graded at 66% of your grade, so it's important to do them all. Now, we've talked about the libraries. Now, let's dive deeper into Pandas. As I said, Pandas is Python data analysis, spelled a little awkward, so that it resembles the nice animal, panda. It's a very powerful package for, as I said, for manipulating tables. It's built on top of NumPy, so it's very efficient. It's very fast. It saves you a lot of effort, so you don't have to write the lower code, lower level Python code. All you have to do is to use this library to manipulate and to extract and to use all the information stored on your tables. It also uses matplotlib, so it's very easy to visualize. And the main data structures are series and the data frame. Okay, I will talk more deeply about series and data frames. So let's start with a series. It's very simple. A series is just an indexed one-dimensional array. Okay, so it's basically a vector, and one-dimensional array is a vector, but it's indexed. So you have the values. It's basically like a dictionary. So you have the keys, which are the indexes, and the values. Okay, which is in this case numbers, floating numbers, 0.25, 0.5, 0.75, and 1. And you can see that they are a floating number, 64 bits, and the index are just numbers. The default values or the default keys are just numbers from 0 onwards. We can use other keys if we want. So here you can see the difference if we use an explicit index instead of omitting the index. So in this case, we omit the index. We don't say what the index is, but we can have the same. You can see that what are we doing here? PD, as you can remember, is shorthand for pandas. Series with a capital S. It's important to. It's a case sensitive. So series with a capital S. And then we just add the values. This is a list of values. So it will put them in a 1D array, but it will index them, okay? So 0.25, 0.5, 0.75, and 1, it will index them and put them in a series, okay? If we tell it what the index is inside of the series, it will have an index, an explicit index that we with the explicit index that we entered. So the same statement, data is PD series, pandas series, 0.25, 0.5, 0.75, and 1. But then we add index equals to A, B, C, and D. We will get an index which are characters or string in this case, A, B, C, and D instead of 0, 1, 2, 3. So if we want to access the data, we can use the key instead. In any case, we use the index, but here we use the key. So data B will be 0.5, like a dictionary, like a hash table, okay? But this is one series. So as you can see in this case, this works like a dictionary. So if we, for instance, if we want to have a series of state names in the US and their population, we will use a dictionary with the names of the states as keys and the values of the population as values. So California, so-and-so people, Texas, so-and-so people, and so on and so forth. And then we convert this dictionary into a series, okay? So the population is now a series that has the same information as in the dictionary population dict. And if we look at the population, we can see that we have, it looks like a series rather than a dictionary, okay? And if we want to see what the population of California, all we have to do is use square brackets, population square brackets California, and we get the number. And if we want to use a bigger slice, we want to see the population of California through Illinois, we can use a population California 2 dots or colon Illinois, and then we get the population of California, Florida, and Illinois. So this is an ordered list. So if we talked about a series, what is a data frame? So a data frame, by the way, is an object. As I mentioned before, Python is object-oriented and everything is an object. So a data frame is an object. And this object is a table. It's a generalized two-dimensional array with flexible row and column indices, okay? So again, if I want to use a dictionary to define my data frame, in this case, I will use a dictionary that has one key with 2 values, call 1 with 2 values 1 and 2, and another key call 2 with 2 values 3 and 4. And then I arrange it into a data frame. What I get is a 2-dimensional table with one column with the values of 1 and 2, and the second column with the values of 3 and 4. And I also get indices. In this case, they are not explicit. So I get the default indices, which are 0 and 1. Any question until now about series or data frames? No questions whatsoever? Yes,
One
please.
question. What if we will not use data frame? What will be the outcome for this?
If you want to, well, you will see. You will get exactly this. If I print D, what I will get is curly brackets denoting a dictionary. Call 1. Let's say if I say print D, so that okay, I will get call 1,
We don't see.
1 and 2. I will have the same information, but not arranged as nicely as a data frame. I will just have a dictionary. Okay.
Okay, thank you.
Same thing that I defined it like this. What the data frame does, it arranges it in a way that gives it meaning, because this has what I see here. There is no meaning, or there is a meaning, but I can't see it very, very easily. What's the meaning of this? I don't know. But if I put it in a table, now suddenly it has a meaning, right? Now this table makes sense. Okay, what this sense, I don't know, because this is just a toy example, but it has a meaning. So the same way that I can construct it from a dictionary, I can construct it from a NumPy array. We did not learn what a NumPy array is, but instead of a dictionary, I can have this. This is basically gives me a random integer numbers from 0 to 10, okay, with the size of 5 over 5. This is what this statement does. Okay, so this is a two-dimensional array with random numbers, with random integer numbers. And now what I say is that I make it I put it into a data frame, and I just give it the column names, A, B, C, and D, these ones. So the indices are automatic, are default, 0, 1, 2, 3, 4, okay? And the column names are what I defined, A, B, C, D, and D. So now again, if the NumPy array is just this, right? It's a 2D by 2D array, but I give it meaning by making it into a data frame and giving it column numbers. They can be A, B, C, D, and E, but they can be other things like weight, height, I don't know, muscle mass, whatever. Okay, so the column names give us meaning to the data frame. What does this column mean? Okay. Okay, so one more way to define a data frame is by using several series. Okay, if I take several series and add them one by another, so I take the same code as before I make a dictionary, okay, like before, of the names of states and the population. I convert it into a series, into a pandas series. Okay, so I have one series. Now I make the same thing with the area instead of the population. So again, the same keys: California, Texas, New York, Florida, and Illinois, same as these. But now it's the area of the country instead of the population. Okay, so now I have another one. I say the series is defined by this dictionary. So I have basically two series, right? One with the population, one with the area. Now, what do I have to do to make it into a data frame? Can you tell me? Anyone has any idea? What am I going to do now? All I have to do now is to combine those two series into one data frame. So I would say, create a new data. Now it's a data frame, not a series, okay? And I say the column of population, I take the population series, and the column of area, I take the area series, okay? So basically that's it. And now if I look at the data frame, what I have is the same keys, because it knows to take the data from California and add the area to the population. So it's the same keys, the names of the states, now I have one column with the area and one column with the population. Okay? Any questions? I think this is very straightforward. Yes, Dinora, any question? Please unmute if you have a question. Otherwise, I cannot hear you. No question? Okay.
Thank you.
Okay, good. Now, another example, I can make, for instance, automatic dates. Okay, if I want to make a range of dates, pandas also have methods to make a range of dates, for instance. Okay, so you see under pandas, under the pandas library, I have a range. Give me just 1 second, sorry. So I have, I can make a range of dates with 6 periods. So what I get is January 1st, or maybe it's, yeah, I think it's January 1st, February 1st, March 1st, so on and so forth in 2013. And now I can take these dates and put them into the index. Okay, I say the index, I make a new table with, again, a random numbers as, and these are not integer numbers, now they are real numbers, okay, float numbers, rand n instead of rand int. In the first example, I used rand int. Where was that? Here. I use rand int, okay, see, rand int. Now I'm using rand n, which gives me floating numbers. And the dimensions are different. Instead of 5 by 5, I use 6 by 4. And I give it the index as dates. And again, we don't see that because it's a picture, but the columns will be A, B, C, and D. So I can use, I can also define the index as I want. Okay, so one more thing, the data types that I can use for pandas data frame and they are they have slightly different names than the ones in native Python type. So a string in Python will be an object. This is the most general type, okay? And I can use any if I have a mix of types, I will use an object. So it can be a string, it can be an integer, a float, another list or whatnot. Okay. In integer int in Python will be called int64 in pandas. This is for let's say historic reasoning, and a float from Python will be a float 64 in pandas. One thing that we saw was datetime. Okay, I can use datetime and see here datetime 64. So this is the type that I don't have in Python, but I do have it in pandas. In pandas, and it denotes the times in nanoseconds. Okay. Now, if I have pandas, usually if I read a file, it will be very large, and I will not want to look at all of the file, all of the data frame at once. So what I use is df head. There is a method for the data frame itself, not for pandas, but for the object or for the class of the data frame. It's called head. If I don't put any arguments, I will get the first 5 rows. Okay. If you remember, we put 6. We defined it as with 6 rows. So between January and May. But if I use head without any argument, I will only get the first 5, regardless of the size. If I use tail, of course, I will get the last 5. If I add an argument such as 3 or 4 or 1 or 10 or whatever, I will get the first 3 or 4 or 10 rows or the last 3 or 4 or 10 rows instead of 5. Okay, so this is head and tail. This is a lot of times this is what we want. This is what we will use just to see what is the data frame constructed of. So what are the names of the columns? What are the rows? What they denote? What kinds of values we have, and so on and so forth. So if I only want to see 3 more methods that I'm using, if I want to see what the indexes are, I will use the attribute. This is an attribute, not a method, df index. The difference between an attribute and a method is that an attribute is just a number that is contained, or values, or even a container. It's not a function. So the index of the data frame is an attribute. It's not a method. We don't use parentheses. And if I use the attribute index, I can see what are the index of this data frame. The same way, if I use columns, I will get the names of the columns of the data frame. And of course, if I just want to see the values without the index and the columns, I will use the attribute values of this data frame. And I will get it like a NumPy array, because this is basically a NumPy array. Okay, if I want to get quick statistics, and this is the last thing I will show you today, because we're almost out of time. And I want to give you a bit of time for questions. If I want to have quick statistics, what I will do is df describe. Now you can see that this is a method, not an attribute. How do we know that? Because it has parentheses. Okay, so df describe, or data frame describe, and this method, what it does, it gives us several statistics. So the count, how many values do we have in each column? What is the mean, or what is the average of each column? Standard deviation, minimum, maximum, and a percentage. The 25th, or the quartile, the first quartile, the median, and the third quartile. Okay, so it will give us these numbers, all of these numbers, and basically this describes us the very, very basic statistics of our data before we want to go into further analysis. So we're almost at the end of our class. Anybody has any questions about what we've seen so far? None whatsoever?
It's pretty clear for me, so I have no question.
What, sorry?
I say everything is clear, so I think I don't have a question. Thank you.
Good. I'm happy that everything is clear. But don't be shy. If something is not clear, don't be shy and ask me now. Okay. So if there are no further questions, then two words to end the lecture. I want you all, if you again, if you had any problems with the installations, don't be shy. We have a forum on Moodle that you can ask, and Elisheva is there to help you. Please already arrange pairs, and in one case 3 people in groups, so you can start working on your project and start working on your exercises, so that you get good grades. Okay. So everybody, I enjoyed the class with you. Have a nice day and see you on Thursday, same time. Bye.
Okay, goodbye. Thank you.